So, unfortunately, the physics of the diode was removed from the curriculum, but we will briefly look because it will help to understand how the diodes work. So, let's consider some element from silicon that has 4 electrons at outer shell. When it's made in solid, those 4 electrons makes bonds with another 4 atoms around, so they share their electrons. So each line represents a pair of electrons. You should know from chemistry that the full outer shell is 8 electrons. So each of them has 4, but they share pairs of electrons, making 8 for each of them. Let's see. But what if we will add some impurity into the element? We will add element with the 5 electrons at the outer shell. So we will have that 4 out of electrons will make bonds with surrounding 4 electrons, but 1 will not have another atom to pair. So we will get, and it will become very weakly binded to the atom and becomes free. So in this way we will get as many as we add atoms of the 5 of the element with the 5 electrons of the outer shell, that many free electrons we will get. Such, and silicon is a semiconducting material, so such semiconducting material with the free electrons as a result of the impurity called N-type. Semiconductor of N-type. We should have some free electrons. Another way we can add impurities if we add the atom with the 3 electrons on the outer shell. Then 3 of those electrons will make bonds with the 3 surrounding atoms of silicon. But there is no 4th electron. But this atom has an electron. What might happen that the electron from another atom, let's say, will jump here and will make these missing bonds. But what will be then here? If atom loses electron, what it becomes? Ion, positively charged ion. And what will happen then? Another electron might jump from here to here. So we will have like a number of the jumps of electrons from one atom to another. But instead of looking into those many jumps of many electrons, we can consider that as a positive charge moving in the opposite direction. And that's called hole. What does it mean hole? There is a place where should be an electron, but it's not there. And that area of the space has a positive charge because we have positive charge. So we will have like this positive hole can move around. Effectively, that electrons move in other direction, jumping in the opposite direction. But we can consider as a positively charged hole moving around. And this type of the semiconductor called p-type. N from negative, P are from positive. And the most interesting thing happens if you will take 2 semiconductors, one N-type and P-type, and put them together. And that is how the diode is created. So if we have a piece of the semiconductor, which this will be P-type, this will be N-type semiconductor. We take two semiconductors, P-type and N-type, and put them together. So here we have some free electrons. Not that many as a metal, but we have some. Here we have some free holes, positive charges. And in nature, processes happen that when there is something a lot in one place, and the place next to it has small number of it, then from where it's a lot, things moving to where it's not many. For example, heat. If you put together hot object and cold object, heat will flow from the hot object to the cold object. If you, for example, drop the, let's say, food dye in the glass of the water, you will see how it will spread around. The molecules of the dye moving where there is no molecule of the dye. This process is called diffusion. So as a result of the diffusion, we will have some electrons will move to the p area. And we will have some layer of electrons created here. Some holes will move here. And there will be some positive charges here. And that creates so-called p-n junction. This is, at least at current moment, is the basic of all electronics. All calculations, all computers, everything comes down at this stage, underline, because the new generation of the computers, quantum computers that are quickly developing, will be much faster, because current computers pretty much came to the maximum possible and theoretically to the possible speed. They cannot be working much faster than now. Yes?
This junction and the N and P types, what are they used for? What they used to show, or what are they used to do?
How they used in the computers, in the like everywhere in the electronics.
What do they show?
They don't show like anything, but they do the calculations happening, and when this p-n junction, it can be open or closed. So that's how calculations in the calculator, in the computer, everywhere happen. When p-n junctions closing and opening. What does it mean? We have here negatively charged here, positively charged here. What we know about the interaction between charges? Positive and positive repel, positive, negative attract, negative, negative repel. So if we will connect here, we will connect positive, and here we will connect negative. We will make this even more negative, this even more positive. And so electrons, here in this area, remember it's n-type, there is no electrons, there is a lot of electrons here. But they cannot go there because negative charges is already diffused, they will push them back. And if we will connect like this, we will say that p-n junction closed. By the way, what I'm explaining is beyond school curriculum, you don't have to know. They remove, but they made that you don't understand physics, what's happening. So, and there is no electrons anyway coming from here. So there will be no current when we connect it like this, there is no current. p-n junction closed for current. No current coming through. But if we connect positive here, and we connect negative here, what will happen? Then, and this here will be some voltage created. Let's say voltage across this p-n junction, let's say 1 volt, for example. As soon as we apply more than 1 volt from the power source, we will have bigger voltage in the opposite direction and current will go through. The PN junction opens. And that's how calculation is done. We're not going into the details how it's used, but that's how calculation is done. Opening, closing billions of such PN junctions. And one device that has just one PN junction called diode. On the diagram, so that's just to briefly give you an idea why diode conduct current only in one direction. Yes?
What has this actually like got to do with everything else? What has this actually got to do with everything else we're learning? Like, what's the context of?
The context is electronic device and how it's used in the electrical circuits. The diode connected in the circuit is on the diagrams. It's shown like this, and this is a diode. This is a diode. How diode shown on the circuit diagram. And if you connect plus here, minus here, we get current coming through. Diode open for current. But if you connect diode, and it's called forward biased, and it can conduct electric current. If we connect it like minus here, plus here, in the ideal diode, current will be equal 0. It does not allow current to go through. That's called reverse bias. It's called reverse bias. So diode is a device that allows current to go through only in one direction. This way, yes. This way, no. So it cannot go. If you connect it like this, there will be no current in the ideal diode. The main area where diodes are used is to make, what is one of the main, to make DC current from AC. For example, you connect your charger to charge your, let's say, laptop or mobile phone, you connect to the power point. What type of current we have in the power point? AC. But to charge battery we need DC. So we need to make from DC current from AC current, and then we will need to use diode. So what diode will do, if we have, let's say this is the current against time. AC current is going like this. But diode does not allow current in two directions. So what diode will does, it don't let this current through. Diode let only this through. Of course, it's not the current that we want the constant DC current, but then we add some other electronic devices, for example, capacitors, and it makes like this, and then we can make it from the AC, we can make constant DC current. But initially we need diode to allow current to cut off current in the opposite direction. That's one of the most important applications of the diode. Now, if we will sketch the current voltage characteristics of the diode, it will look the next way. Current, voltage. And first I will draw the characteristic of ideal diode. Ideal diode, this will be reverse bias. This is forward bias. For ideal diode, if we connect voltage in reverse, there will be no current here at all. And it will be zero current up to certain voltage, which depends on the voltage across that PN junction. And let's say this is 1 volt. And then when we get the applied voltage becomes equal, the voltage across PN junction, diode opens and current going through. And as I'm saying, in ideal diode, it will go up. That is the current voltage characteristic of the ideal diode. Of course, in reality, it does not work exactly like that. So, in reality, it will be current going like this. So it's not like completely zero and then vertically up. But for all problem solving, we will be considering that diode as ideal to make it more simple. Also, what is interesting, in reality, there's still some current can get through in the reverse direction. In reality, we still will have some current that can get through in the opposite direction. But difference is, in this scale, that will be microamps. This scale, that might be milliamps or amps. So let's say milliamps, can be amps. So current in reverse, it's not zero. Like ideally we say it's zero, it doesn't allow current at all. In reality, there can be some current getting through, but difference, how many times 1 amp greater than 1 microamp? Million times. So difference between the current and the forward bias and reverse bias million times. So for most cases, except photodiode, we disregard this reverse current and you can see that it is zero. Makes sense how the diode works. It's allow current only in one direction. As soon as voltage across diode in forward bias reach certain value, for each diode it's different. For each type of diode is different. As soon voltage get to certain value, diode open and current can go through. If you have voltage less or we have voltage connected the opposite direction, opposite way, there is no current through the diode. Make sense? One of the most important applications of the diode now is the LEDs, light emitting diodes. So LED are diodes. And when we have current coming through the diode, what happens when electron moving through that meet with the hole? What will happen?
Jumps there.
It jumps into the hole. And so its energy of the electron, it's filled that hole. And it's losing its energy, have less energy. And that energy might be released in certain types of semiconductor, released as a light. That's how light is created in the LED. When the electrons moving through the diode jump, falling into the holes. And the difference in energy released as a light. On the diagrams, LEDs are almost the same as diode. The only thing is added couple errors. which means it is a light emitting diode. Not just diode, it has all properties of the diode, it's allow current only in one direction. But when current getting through, LED emits light. Let's consider an example. If we connect LED to the battery and we include a resistor, if you want diode to emit light, which pole of the battery has to be on this side, positive or negative? Positive. So we need to connect battery like this. And question is, and let's say battery has 6 volts. Yes, sorry, question?
Yeah, why is the positive connected to the positive side?
Because current going through only when plus here, minus here. If you connect other way around, there will be no current. And for LED to emit light, we need diode to be open. Current getting through. Diode allow current only one way. So, voltage across diode all the time 1 volt. Because it's, as soon as open, it stays constant, 1 volt. So what will be, we have 1 volt across here. What will be voltage across the resistor?
5 volts.
Total voltage supplied 6 volt. What type of connection is this? Series or parallel? Series. In series, what you know about voltage? They adds up. So total is 6. Out of those 6, 1 volt will be across the diode. What's left? 5 volts. And it does not matter, whatever resistor you will put here, the voltage there will be 5 volts. Because 1 volt across diode determined by the diode. As soon as made, it has its own opening voltage. As soon as it's open, we have voltage stay the same. So what value of resistance will determine what the current in the circuit. Let's say we connect a resistor of 20 ohms. What will be the current in the circuit? What will be the current? How are we finding current? Ohm's law. Voltage over resistance. Which voltage we need to take? Yes, voltage across resistor. So we get 5 volts across divided by 20 ohms equal 0.25 amps or 250 milliamps. If we connect, for example, instead of 20, we connect a resistor of 50 ohms, what will be current in the circuit? Will be 100 milliamps. Make sense? And we must have, you never connect diode forward bias by itself. We always connect with this, with the resistor. Why is that? Because if there will be zero resistance here, and we have, as soon as diode open, the current increases, what will happen with that diode? It will melt or burn out. That's what students do, because you will be doing prep with LEDs, and what students sometimes do, they forget to connect this limiting resistor needed to limit current, and they burn LEDs. So this one needed to limit the current through the LED. Yes?
Right, but wouldn't the at the 6 amps because if the resistance is 0, then it would just be 6 0, which would be.
We have resistance of the open diode, we take ideal so is 0. And current equal 6 volt with 6 divided by 0 equals infinity. It will be, of course it will become infinite because diode will blow up way earlier than that. Makes sense how to calculate the circuits with the diodes. You're using voltage across diode stay constant. And it's always voltage across resistor will be voltage supply minus voltage across that diode. Last type of diodes, photodiodes. Photodiode is connected in reverse, or more exactly, it's unbiased. And put your hands up who have solar panels installed there. And those solar panels, they are actually photodiodes. So what LED does? What energy transformations LED does? What energy we put into the LED? Electrical. We put electrical energy. What we get out? Light. Photodiode is opposite. When we put light in, it produces electrical energy. And the solar panels is thousands and thousands of photodiodes connected together. Because of photodiode, we have differences that the arrows are toward the diode, because it's receiving light, not emitting light, it's receiving light. That's photodiode. And photodiode works in reverse. So if we have current voltage characteristic, we're looking into these beats. That will be where photodiode works. Now, in the all problems that you will be solving, our focus is on fusion diodes or LEDs, very little problems with the photodiodes, but that's what it is. And photodiode, it's actually don't require, it acts as a power source by itself. We don't need any power supply if we connect it to a resistor and we have light falling on the photodiode, we will get current going through. You'll get current going through. Because what happens when light is absorbed, but photodiode, it's create the electron and hole pair. Some electron of the atom that absorbs that light, electrons becomes free, we'll get free electron and free hole. And we'll get current stuff. That's how diodes are working, and we'll get to solving problems.